Have you ever wondered how software systems are developed? Well, that's where the concept of a software process comes into play. This is a set of activities, methods, and practices that guide the development, maintenance, and management of software systems. It's like a roadmap leading to the successful completion of software projects, on time, within budget, and with high quality. The software process revolves around the software development lifecycle, which outlines the stages a project undergoes from initiation to deployment and maintenance. It also involves different process models, such as waterfall and agile, defining the sequence of activities and their relationships. Key activities in software processes range from gathering requirements to designing, implementing, testing, deploying, and maintaining the software. And let's not forget about the continuous process improvement, which is vital for enhancing the efficiency and effectiveness of these processes. So let's dive in and explore the fascinating world of software processes. The backbone of any software process is the software development lifecycle, or SDLC. It's like a roadmap that guides developers from the inception of an idea to its final manifestation as a software product. The SDLC begins with requirements analysis. This is the stage where developers identify the needs of the end users and define the functionality that the software should provide. It's all about asking the right questions to understand what the software needs to do. Next comes the design stage. This is where developers sketch out how the software will work. They create blueprints detailing the software's architecture, database structure, and user interface, among other things. It's like drawing the blueprint for a house before starting construction. The implementation stage is where the actual coding happens. Developers translate the design into a language that computers can understand. They write lines of code that will eventually become the software product. It's like building the house according to the blueprint. Once the coding is done, it's time for testing. In this stage, developers check if the software works as expected. They look for bugs and errors and make necessary corrections. It's like inspecting the house for any faults or defects. The deployment stage comes next. This is when the software is delivered to the users. It's installed and set up in the user's environment, ready for use. It's like handing over the keys to the house to the new owner. But the journey doesn't end there. The final stage is maintenance. Developers keep an eye on the software, making updates and improvements as needed. They fix any issues that come up and add new features based on user feedback. It's like keeping the house in good condition, doing repairs and renovations as needed. Each of these stages is crucial, and skipping any one of them could lead to problems down the line. The SDLC is designed to ensure that software is built right the first time around. It's a cycle, not a one-way street, and it's what keeps the world of software development spinning. The SDLC provides a structured approach to software development, ensuring that all important aspects are considered and addressed. Different software projects may require different approaches, and that's where process models come into play. Just like a blueprint for a building, process models provide a structured approach, defining the sequence of activities and their relationships in software development. Let's dive into a few examples. First up, we have the waterfall model. Picture a series of cascading steps, each one flowing seamlessly into the next. This model is linear and sequential, with distinct phases such as requirements analysis, design, implementation, testing, and deployment. Each phase must be completed before moving on to the next, making it suitable for projects with well-defined requirements and minimal changes. Next, let's touch on the agile model. Agile is all about flexibility and adaptability. Instead of a single linear path, Agile involves iterative and incremental development. It's like building a structure brick by brick, with frequent feedback loops and close collaboration with the customer. This model is perfect for projects where requirements are likely to evolve, or where delivering working software quickly is a priority. The spiral model is another interesting approach. Imagine a spiral staircase with each loop representing a phase of the software process. This model combines the structured approach of waterfall with the flexibility of agile, adding a unique twist, risk analysis at each phase. It is particularly useful for complex high-risk projects. Lastly, we have the iterative model. This model involves repeating the same cycle, requirements, design, implementation, and testing, over and over until the final product is ready. It allows for continuous refinement and improvement, making it a good fit for projects where the final requirements are not clear from the start. So you see, each process model has its own unique characteristics, advantages and disadvantages. The choice of model can depend on a variety of factors, including the nature of the project, the team's expertise, and the customer's needs and expectations. Choosing the right process model can significantly impact the success of a software project, so it's crucial to understand these models and make an informed decision. After all, a well-planned journey often leads to a successful destination. So, what exactly happens during software development? Let's look at the key activities. First, we have requirements engineering. This is where we gather, analyze, document, and validate the needs and conditions to meet for a new or altered product. We're essentially asking the question, what does the software need to do? We're establishing the what before we get to the how. Then comes design. Here, we're creating high-level and detailed designs of the software system based on the requirements we've gathered. This includes the software architecture, the user interface, and data models. It's like drawing the blueprint for a house before starting construction. Next up is implementation. This is where the real coding begins. Developers write code and build the software system according to the design specifications. They transform the design into a functional piece of software. It's like turning the blueprint into a real, tangible house. After implementation, we move on to testing. This is where we verify and validate the software to ensure that it meets the specified requirements and quality standards. We're looking for bugs, errors, and any other issues that could affect the software's performance or functionality. It's like doing a home inspection to make sure everything's in order. Then we have deployment. This is where we install and configure the software in the production environment. It's like moving into the new house and setting up all the furniture. Finally, we have maintenance. After the software is deployed, it needs to be maintained. This involves making modifications, updates, and enhancements to the software to address issues and meet evolving requirements. It's like doing home repairs and renovations to keep the house in good shape. Each of these activities plays a vital role in the development of a high-quality software system. Software processes are not set in stone. They can and should be continuously improved. The concept of continuous improvement is ingrained in the world of software development. The goal is to enhance efficiency, effectiveness, and adaptability, allowing teams to deliver better outcomes faster and with fewer resources. This is not a one-time effort, but rather a relentless pursuit of excellence that spans the entire life cycle of the software. One popular method for process improvement is Six Sigma. Originally developed by Motorola, Six Sigma is a data-driven approach designed to eliminate defects and reduce variability in processes. It provides statistical tools to identify the root causes of problems and make informed decisions, helping to improve the quality of software output and customer satisfaction. Another method is Lean, derived from the Toyota production system. Lean focuses on eliminating waste, optimizing flow, and delivering value to the customer. In software development, this translates into practices such as just-in-time requirements, incremental development, and continuous integration, which aim to increase speed and flexibility while reducing overhead and rework. The Capability Maturity Model Integration, or CMMI, is a framework that assesses and improves the maturity of software processes. It provides a roadmap for process improvement, from initial ad hoc processes to optimized processes that are measured and controlled. By following this roadmap, organizations can improve their ability to meet project goals and customer requirements. These methods are not mutually exclusive, but rather complementary. They provide different perspectives and tools that can be combined and adapted to the specific needs of each organization and project. It's not about following a method blindly, but about finding the best way to improve the process and deliver value. Yet, process improvement is not just about methods and tools. It's also about people, culture, and mindset. It's about empowering teams to experiment, learn, and improve. It's about fostering a culture of collaboration, transparency, and continuous learning. And it's about embracing change as an opportunity, not a threat. In conclusion, continuous improvement is a journey, not a destination. It's a mindset that drives innovation, quality, and customer satisfaction. It's a key factor in the success of any software organization. So never stop improving, because as we all know, good enough never is. Continuous improvement helps software organizations stay competitive and deliver better products. We've covered a lot of ground today, from the basics of software processes to different models and key activities. We've journeyed through the software development lifecycle, understanding how a project evolves from initiation to deployment and beyond into maintenance. We've explored various process models that structure these stages, such as the waterfall, agile, and spiral models, each with their own unique strengths and challenges. We've delved into the heart of software processes, examining key activities such as requirements engineering, design, implementation, testing, deployment, and maintenance. We've also underscored the importance of continuous process improvement using methods like Six Sigma, Lean, and capability maturity model integration. Remember, these processes, models, and activities aren't just theoretical constructs. They're practical tools that guide us in creating robust, efficient, and high-quality software systems. Understanding software processes is key to developing high-quality software systems. Remember, a well-defined process is the first step towards success.